Hello friends, I hope you're all doing well. As you know, we have studied some of the sections of integration in chapter 5. In general, we've studied the rules of integration, the properties of integration, how do you calculate them, definite integration, indefinite integration, and area between curves, area between function and the x-axis. In general, today I'm not going to start with any new section. I'm generally going to solve some extra examples on those sections that we have studied in general. Of course, I will start with the simplest ones so that you remember the most general properties and rules of integration, and then we will go through substitution method and area between curves and the others. Of course, I've written some examples here. I will do more uh, upcoming ones. So the first integration that we have got is an indefinite integration. We have got an integration of minus 3 dx. We said if you have got a constant, we are simply adding an x next to it. So that will be minus 3x and of course plus c when we have got indefinite integration. The second integration is integration of dx. Here we have got nothing in between the integration sign and the dx, but when we have got nothing in here, what does that mean? That means, of course, there is the presence of 1 in between those two things. So that is considered as integration of 1 dx. Since it is 1 dx, so that integration is equal to x plus c. Why are we adding that c here? Because we have got indefinite integration. That integration, we have got integration of x under the cubic root minus 3x to the power of minus 2 over 3 plus 6. As you know, when we have that kind of x's, square root, cubic root, fourth root, and those ones, first we are changing that 1 to a power. Okay, so the power will be x to the power of 1 over 3. This one is already a power and that one is a constant. When we are doing integration, how do we deal with the power? Of course, we are adding or we are increasing the power by 1. So integration of x to the power of 1 over 3 will equal to what? Will equal to x to the power of 1 over 3 plus 1 all over 1 over 3 plus 1. 1 over 3 plus 1 is equal to what? Of course, we have to equalize the denominators. I'm doing it here in general in small steps because you're already familiar with those things. That will be x to the power of 1 plus 3 is equal to 4 over 3 all over 4 over 3. Okay, that's the integration of x to the power of 1 over 3. When you're increasing the power by 1, it will be 4 over 3. Okay, and that one is minus 3 x to the power of minus 2 over 3 plus 1 is equal to what? Let's calculate it here. Minus 2 over 3 plus 1, because we're increasing the power by 1. Of course, we have to equalize the denominators. That will be minus 2 over 3 plus 3 over 3. Okay, because we are changing this one to 3 over 3. So that one is equal to what? If you look at this, it will be 1 over 3. So integration of this x will be x to the power of 1 over 3 all over 1 over 3 plus 6 is a constant, so that will be 6x plus c, all in general. Okay, let's come to this one. We have got integration of 1 over 2y minus 2 over y squared. How do we solve that integration? Of course, we have to first change it to powers. 1 over y is equal to what? Integration of 1 over y, or let me write it as it is, 1 over y. For this one, we do not need to change it. Minus 2 multiplied 2 y to the power of minus 2. Okay, dy. I didn't change this 1 over y because you know that when the power is negative 1, we are considering other cases. We are not dealing with the power increasing power by 1. But here minus 2 over y squared, I will change it to minus 2 y to the power of minus 2. Okay, now here I have got 1 over 2. Okay, what is integration of 1 over y? We know that that's equal to ln of absolute value of y minus 2 integration of y to the power of minus 2. When you're increasing the power by 1, it will be minus 1 over minus 1 all plus c. Okay, so that 1 over 2 is still remained here. Integration of 1 over y, since the power is negative 1, that will equal to ln of absolute value of y. Minus 2 is a constant, I'm writing it here. Integration of y to the power of minus 2 is equal to, when we are increasing it by 1, is equal to y to the power of minus 1 over minus 1 plus c. Now let's come to this one. We have got this integration. Let me do the distribution over that integration. If you look at this one, it will be 2 integration of e to the power of u du. Of course, you can do it directly without distributing it, but I'm distributing it so that you see the steps how they are done. That one is plus, I'll take the 6 out, integration of 1 over u du. Okay, I took that 6 out, that will remain 1 over u du plus integration of ln of 2 du. Students are always making mistakes when they are solving that integration of ln of 2, although it's so simple. Okay, that 2 is here. Integration of e to the power of u. I know integration of e to the power of x dx is e itself. So here it's just a change of variable. E to the power of u du has got no difference with e to the power of x dx. So since I have got the derivative of the power right next to it, so that one will be e to the power of u plus 6 integration of 1 over u du is equal to what? Ln of absolute value of u. Okay, plus, how about integration of ln of 2? That ln of 2 is only a constant. It's considered as a constant. There is no u with it, so it is just remained as a constant. So that one will be ln of 2, okay, multiplied to u, not ln of 2u. Okay, you are not writing ln of 2u. That is wrong. This is ln of 2, okay, multiplied to u separately. They are not together. And all plus c. Why? Because the integration that we have got is an indefinite integration. Okay, if you look at this one here, what do we have? We have got y to the power of 3 multiplied to 2y in the bracket plus 1 over y. Here we do not need substitution method. Okay, we are simply multiplying this one to inside and adding the powers with the y. So that integration will equal to what before solving it? Look, I'm writing the integration sign again. Why? Because I'm not solving it yet. That y to the power of 3 multiplied to 2y, that will be 2y to the power of 4. That I haven't increased the power by 1. Okay, it's not the integration. I haven't done the integration yet. I have just multiplied this one to inside. So y to the power of 3 multiplied to y, it will equal to y to the power of 4 plus this one is y to the power of minus 1. This one is y to the power of minus 1. So y to the power of 3 multiplied to y to the power of minus 1, decrease the power by 1, that will be y to the power of 2. Okay, all dy. Now the integration can be solved easily, as you see. Look, we didn't need substitution method because it's already solvable easily. So that will be 2 to the power of y to the power of 5 over 5 plus that will be y to the power of 3 over 3 all plus c. Okay, so if you think a little bit about those kinds of questions, you do not need to go further for difficult steps. You can just solve it easily. How about this one? Integration of ln of e to the power of minus x squared. This one is inside the ln, please. It's not two things separate. It's not multiplication between ln and e. So here we also again do not need substitution method. This one is solved very easily. If you remember from the properties of logarithmic functions and exponential functions, we said they are inverses of each other, so they cancel each other. What remains inside the integration sign? Look, I haven't solved the integration yet. I'm just doing the operation inside the integration to make it simpler for solving. So ln and e cancel each other since they are inverses of each other. What remains here? The only thing that remains is minus x squared dx. Okay, and this one is very simple to be solved. That will be minus x to the power of 3 over 3 all plus c. Okay, so far we had indefinite integration. The integrations that we had no limits. I mean lower limits, upper limits, or we can say the bounds of the integrations. We didn't have them. That's why we were adding plus c. We were adding c at the end of the steps that we were doing for the integration or for integrating the functions that we had. But now here we have got a definite integration. What is a definite integration? That means I have got bounds for the integration. The integration runs from a number to another number. So this one, if you look at this, I have got integration of pi dx. Pi is a number, it's a constant number. So integration of a constant number is equal to what? It's equal to pi x. Okay, for example, if it was integration of 3, that would be 3x. If it was integration of 2, 2x. Pi is again a number, so the integration is pi x. But here I'm not adding c to it. Why? Because I have got definite integration. Instead of c, what shall I do? I shall write the bounds here. Okay, like that. Please do not do the integration sign because we've already taken the integration here. We are just writing the bound, doing a bar here, okay, from minus 1 to 2. Since it is definite integration, so I have to first put 2 instead of the x and then minus 1 into the x. So how can I deal with this one? That will be pi multiplied to 2, okay, because I'm putting 2 inside here, minus, then that will be pi, okay, multiplied to minus 1. Let's solve this one. That will be 2 pi minus minus is equal to what? Is equal to positive pi. So 2 pi plus pi is equal to 3 pi. Look, here we do not have any constancy because we are inputting values inside, so we do not get any c outside here. Okay, let's look at that integration. Again, we have got definite integration of that function. It's an easy function. E to the power of t, of course, this t has got, as I told you, has got no difference with the x, but instead of x here t is used. What is the integration of e to the power of t? Since it's something simple, so it is directly itself. Okay, we have got minus e to the power of minus t. What is the derivative of minus t? It is negative 1. We have got the negative right next to it. So what is that integration equal to? It is equal to e to the power of minus t. Okay, why this negative changed to positive? Because if you look at here, this one, that integration is like that, from 0 to 1 over 2 e to the power of t dt. Okay, plus integration from 0 to 1 over 2 minus e to the power of minus t dt. That integration is simple. It is equal to e to the power of t, okay, running from 0 to ln of that, sorry, that's ln of 2. And that integration is, I have got here the a problem with the power. It is minus t instead of t. So when we have got a power, a problem in a power, we have to think about the derivative of the power right next to it. What is the derivative of the power? Minus t. It is equal to minus 1. The minus is right next to it, so the integration is equal to itself, e to the power of minus t. And we are putting that positive sign here, so that's why the integration is like that. Now, instead of c, again, what do we have? We have got the bound running from 0 to ln of 2. What is that equal to? For of course, we are inputting this one into here first, so that will be e to the power of ln of 2 plus e to the power of minus ln of 2, okay, all minus, then we're inputting 0 into the equation, I mean the function that we have got, e to the power of 0 plus e to the power of minus 0. Let's calculate this one. It's also easy. These two are inverses of each other, okay, so that will be 2 okay? And here, if you remember from the properties of a logarithm, how can we solve this one? Minus ln of 2 is equal to ln of 2 to the power of -1. I'm putting that negative up here. So that one is equal to what? E to the power of ln of negative 2 to the power of -1. E and ln cancel each other. Be careful, we are not cancelling e and ln like that because there is an obstacle here, okay? We have to get rid of that negative. How? By taking it back to here, and then we can say that those two are inverses of each other and cancel each other. So here that will be plus 2 to the power of -1 minus, that minus is that one, e to the power of 0 is equal to 1 plus this one is again e to the power of 0 is equal to 1. If you look at this one, that will be 2 plus 1 over 2 minus 2. These two cancel each other and the result is simply equal to 1 over 2. So there is nothing complicated here. You just need to do some calculations more than the others. Now here in that example, we have got an integration running from 0 to 1 of 60 over t squared plus 1. If you look at this one, we can consider this integration in two ways. Either we can say directly that we have got the derivative of the denominator up in the numerator, and that's equal to the ln of the denominator, or you can solve it by substitution method. First, let me solve it by the simple way. Okay, here I have got denominator, okay, to the power of -1. All this one is to the power of 1. Of course, when it goes up, it becomes to the power of -1. So we say that since we have got derivative of this one up there, okay, but the 3 is extra here, or let me make it like that first, and that will equal to what? Integration from 0 to 1. I will take 3 out of here. What remains? 2t remains here over t squared plus 1, and dt, of course, right next to it. Now I can easily say that the derivative of this one, I have it up there, okay? Since I have got the derivative, so that's simply equal to what? Equal to the ln of the denominator. So that will be t squared plus 1 running from 0 to 1. Okay, that is the fast step, easy step to do. Let me solve it by substitution method. So using substitution method, that's the solution. Okay, you're inputting 1 into here, 0 into there, and you will get the solution. But let's also do it by substitution method. Substitution method. Since we've got this one, we are considering u to be t squared plus 1. We said when we have got substitution method, the thing that we directly have to do after choosing the substitution variable, we have to find the derivative of it, and the derivative is equal to 2t dt. After this one, what do we have to do? We have to change the integration from variable t to variable u. So that one is equal to what? The integration. We said when we are changing the variables, we are not writing the bounds. Why? Because that bounds are given for t. They are not considered for u. U is a new variable. We have described it. So we are not writing from 0 to 1. We are simply writing it as an indefinite integration. So let's do the change that we have got here. T squared plus 1 we have considered as u, okay. 60 dt, how can we get this one? Here I have got 2t dt. How can I change that to 6 so that I consider all that together? I'm simply multiplying it by 3. Okay, I can change that to 6 by multiplying it by 3. So 3 du is equal to 60 dt. Now 60 dt is equal to what? Because we said we have to change whatever variable we have got into the new variable. That's equal to 3 du. Now that's easy to solve. 3 over u is equal to what? 3 ln of absolute value of u. Here we have to change the variable of u back to t itself because we have to get a solution consider t in it. So that one is equal to what? That one is equal to 3 ln of absolute value of t squared plus 1. Here, since the variable is back to its normal, so we are writing the bound from 0 to 1. Okay, now look, here we get the same result either you're using substitution method or doing the direct steps. Okay, and now from this step, what shall we do? We have to input those numbers into there. So I have got 3 outside, ln of absolute value of 1 squared plus 1, okay, minus, sorry, here is an absolute value, ln of 0 squared plus 1. That's equal to what? 3. That will be ln of 2 minus ln of 1 is equal to what? Because that 0 will be gone. Ln of 1 is equal to 0. So the result is 3 ln of 2. And you leave it like that because you do not have a calculator for solving it. We've got another example, integration running from e to e squared 1 over x ln of x. Solving this one, you can solve it like the previous one, directly by considering the derivative of ln right next to it, or you can use substitution method. So let's use substitution method because I know that your eyes cannot catch that fast step. So let u is equal to ln of x. Directly after u, what do we have to do? We have to find the derivative of that new substitution. So the derivative of ln of x, that's equal to 1 over x dx. So we have to change the integration from x variables to u variables. That integration is equal to what? Without writing any bound because we have changed the variables. That will be 1 over ln of x is considered as u, so I will write u here. Okay, what remains when I'm considering, look, we can write this one as what? Let me make it good for you. That will be 1 over ln of x multiplied to 1 over x dx. Okay, look, this one I can rewrite it as that one. Why? Because when I'm multiplying this to that, it will be again x ln of x. I'm writing it like this so that you see how am I changing the integration by substitution. Okay, so 1 over x will be 1 over u multiplied to 1 over x dx is equal to what? 1 over x dx is equal to du. That one is an easy integration. 1 over u is equal to ln of absolute value of u. Look, here we do not have bounds and we are not writing c here because it's a definite integration. We have to change u back to x itself. So u is considered as ln of x, so that will be ln of absolute value of ln of x. Okay, and the integration is running from e to e squared. Look, we have got ln of x. So that one is equal to what? Of course, we have to substitute first this one into it. So that will be ln of e to the power of 2, okay, minus ln of absolute value of ln of e. Okay, look, we have got ln of e squared, ln of e. That one is equal to what? These two are inverses of each other. Sorry. These two are inverses of each other. So the only thing that remains is the power. It will be ln of absolute value of 2 minus ln of e is equal to 1. So that will be ln of absolute value of 1. You can skip those steps because they are easy. Okay, you can directly come to ln of 2 minus ln of 1. Ln of 1 is equal to what? Is equal to 0. So the integration result is equal to ln of 2. We have got another example, integration from 1 over 3 to 1 over 2 e to the power of 1 over x all over x squared dx. We are using first, before using substitution method, let me rearrange this one, rewrite this one in another way. I can write this integration as e to the power of 1 over x multiplied to 1 over x squared dx. Okay, so that it would be easier for you to see the substitution, how it is made. Okay, because this one, when you are multiplying it to that, again it will go to the numerator and it will give me the same thing like that. So let's do the substitution method. Let u equal to 1 over x. We said when we have got e to the power of something, in general we are using the power of e to be the substitution. And of course, after the substitution, what do we have to do? We have to find the derivative of this one. What is the derivative of that? It's equal to, of course, this one is equal to x to the power of minus 1. So the derivative of this one is equal to minus x to the power of decreasing the power by 1. Look, that's the derivative, okay? It's not integration. So we're decreasing the power by 1. That will be minus 2. So this one is equal to what? Is equal to minus 1 over x squared. Okay, this one is coming down. Sorry, a dx is missing here. Okay, so that one is equal to dx. So in general, du is equal to what? Is equal to minus 1 over x squared dx. Okay, this one is equal to that one. Now we have to change the integration. Okay, how do you change it? That's equal to integration. Again, we are not writing the bounds because those bounds are for x, not for u, and we are changing the integration. E to the power of 1 over x is equal to what? E to the power of u, because we have considered 1 over x as u. Now what's remained here? That bit is remained to be changed, and now I have got this one here. I'm simply multiplying both sides by minus. Okay, so that I will get the same thing. That so in general, 1 over x squared dx is equal to what? Is equal to minus du. Okay, what is that integration equal to? Solving it, that's equal to minus e to the power of u. It's simple. Integration of e to the power of u is equal to itself with a negative outside. Now I'm changing this one back to its original form. So that one is equal to minus e to the power of, instead of u I have got 1 over x, and the integration runs from 1 over 3 to 1 over 2. Again, as I said, do not write the integral sign because we've already taken the integration. We're just writing those bounds. So that one is equal to what? First we're inputting e to the power of 1 over 2 minus, okay, that minus I have taken it out, so it's not doing anything to that negative inside here. That will be e to the power of 1 over 3. So that one is equal to what? Minus e to the power of 1 over 1 over 2 is equal to 2, minus e to the power of 1 over 1 over 3 is equal to 3. Simplify this one more, that will be e to the power of 3, because that negative is multiplied to this one and that one. So that will be positive e to the power of 3 minus e to the power of 2. That's the required result. I think we've solved lots of integrations, okay, of all the types: definite integration, indefinite integration, substitution method, without substitution method. Now I'm gonna solve an easy example for you on the regions, I mean on the area between curves. We are given a question like that. It's very easy, and also the questions that are in your assignments are so easy for finding the area. We've got find the area enclosed by the curve y, that's equal to x squared minus 1, and the x-axis. Although the bounds are not given in here, but we can easily find them, because we know when the area is required from you between a function and the x-axis, you have to find the intersection of the graph with the x-axis, so that you find the bounds of the integration. Okay, so How do we find this one? How is the graph of this one? The graph of this is very easy. Even if you do not know how to sketch the graph of this one, just doing the steps will give you the same result and the easy result. We know that x squared is here, okay? X squared minus 1 is what? It's the same x squared but coming down minus 1 unit. So the graph of that function is something like that. Okay, here is negative 1. Let's solve it. How do I find the bounds? That will be x squared minus 1 equal to 0. I will equalize it to 0. Why? Because I'm finding the intersection of that function with the x-axis. How do I find intersection x-intercepts? By equalizing the function that we have got to 0, because x-intercept is found by letting y equal to 0. Okay, now let's solve this one. That will be x minus 1, x plus 1, all equal to 0. So that will be x minus 1 is equal to 0, or x plus 1 is equal to 0. So x is equal to 1, or x is equal to minus 1. So what are the bounds? The bounds are minus 1 and 1. Let's do the integration, because when it says find the area, we have got what? We have got integration. So the area runs from minus 1 to 1. What is the function that we have got? It's x squared minus 1 dx. Okay? Solving this one is easy, of course. X to the power of 3 over 3 minus x. Okay? And the area is between minus 1 and 1. Okay, so that means we're finding that bit. Okay, here is negative 1 and here is positive 1. Okay, now let's input those values into here. Let me rewrite this one. X to the power of 3 over 3 minus x, and that's between minus 1 and 1. That would be 1 to the power of 3 over 3 minus 1. Okay, that minus 1 is not this one. I have input this one into here, and then minus, that's the rule from the definite integration. I'm putting negative 1 into here. That will be negative 1 to the power of 3 over 3 minus, when I put minus into here, it will be minus 1. Okay, I'm not vanishing that negative in here. I still have it here. So that one will be 1 over 3 minus 1. Okay, then minus 1 to the power of 3 is still minus 1 with that negative, because we also have to multiply this negative to inside. It's for both of them, this one and that one. So that will be plus 1 over 3. Okay, it is minus 1 over 3. Multiplying it with this negative, it will be plus 1 over 3. Minus multiplied with minus, it's positive 1. Positive 1 multiplied to that negative, that would be negative 1. So 1 over 3 plus 1 over 3 is 2 over 3. Minus 1 is minus 2. Equalizing the denominators, that will be 2 over 3 minus, this one will be 6 over 3. So this one is equal to what? That's equal to minus 4 over 3. Okay, because 2 minus 6. Why is it minus 4 over 3? We are talking about area. Area must not be a negative number. But here we got a negative number. We got minus 4 over 3. Why did we get that? Because I told you at the beginning when I was explaining the area, I said if it is a negative value, that means the area is below the x-axis. And if it is a positive value, that means the area is above x-axis. If you look at here, the area that we have got is below the x-axis. That's why we got a negative number. You can simply write area is equal to what? Absolute value of minus 4 over 3. So that's equal to 4 over 3. That's all about the sections that we have studied previously. I think they're easy. Your assignment is easy. You've got easy questions in it. It is, yeah, the assignment that you can do it in only an hour. So easy for you. Hope you would understand the video when you're watching. Have a good time and bye.